Hey, welcome to Wednesday. Well, we just have 2 more math lessons this year. And today's and tomorrow, and that'll be it. We aren't even having a test on integers, but these 2 practices that you're doing and the snapshots are really important. So make sure you're being accurate with those. All right, today we're going to talk about 11.4, multiplying integers. It's on page 592, all right? 592 in your book. So multiplying integers, you'll be glad to know, is much simpler. In fact, multiplying and dividing integers, much simpler than adding and subtracting integers. Yes, it is. And so let me show you how this works. First off, we got some rules. I'm not going to do any modeling about multiplying integers, but we got some rules that apply all the time to multiplying integers. First off, if both the factors that you're multiplying, the numbers you're multiplying together are called factors. If both the factors are positive, then the product, your answer is positive. Okay? So we always, you went back, I guess in 2nd grade you were going 5 times 3 is 15. Well, they're both positive. 5, positive 3, you multiply them together, you get a positive 15. That was really simple. All right? Here's something new. If they're both negative integers that you're multiplying together, for instance, negative 3 times negative 5, they're both negative integers. The product is positive also. So basically what this means is, if the numbers you're multiplying together have the same signs, they're both positive or they're both negative, your product will be positive. No exceptions. The product will always be positive. So here we have negative 3 times negative 5 is positive 15. Negative 7 times negative 7 is 49. So if they have the same sign, it's really simple. Same sign, positive product, positive answer that you circled. Now what if they have different signs? What if one is positive, one's negative? Then the product is negative. Your answer is negative. That's simple, isn't it? You don't have to think about adding, subtracting, and all this kind of stuff. All right, so let's say it's negative 3 times 5. Here, I have a negative 3 times a positive 5. They have different signs. I know 3 times 5 is 15. Now I got to decide, is it a positive 15 or a negative 15? Well, since they have different signs, it's a negative 15. Pretty simple, isn't it? How about 7 times negative 7? Well, here they have different signs. I know 7 times 7 is 49. Is it a positive 49 or a negative 49? Well, they have different signs. All right? Those factors have different signs. Therefore, the product is a negative product. It's negative 49. So let's review that again. If they have the same sign, the answer, the product is what? Positive. If they have different signs, the product is what? Negative. No exceptions. That's pretty cool. Now, let's use this in a real world situation. The Bay of Fundy. It's a really fun place, all right? Unless you get caught in a giant clam, your foot there in low tide. And then the tide comes in, and that's, it goes up, and that's the end of the story, all right? But let's suppose at the Bay of Fundy, the tide, high tide and low tide, 6 hours between those two. The high tide and low tide take 6 hours to get down to the low tide. And every hour, the tide at the Bay of Fundy drops 4 feet. It decreases 4 feet every hour. Now, our hole in our area here, in Tampa Bay area, 4 feet is the whole difference, right, between high tide and low tide, 4 feet. But here at the Bay of Fundy, every hour it drops 4 feet for 6 hours. Okay? So what is the total drop? What is the total decrease in the number of feet? Well, I'm going to have 6 whole hours, right? Times every hour a negative, right? It decreases 4 feet. So here I have a positive times a negative. We just learned if you have different signs that you're multiplying together, what is your product? It's going to be negative, right? So 6 times negative 4 is negative 24. So it decreases. That's what that negative sign tells you in the story column. It decreases between high tide and low tide 24 feet. I mean, 24 feet, that's way up here to the ceiling of this room, way up there. That is a high and a low tide by the time it finishes. So anyway, that's how you would use this kind of information in the real world. All right, let's practice some of these. What's negative 7 times 6? Well, first thing Mr. Frazier does is, I think, what is 7 times 6? Well, 7 times 6 is 42. Now I got to decide, is it a positive or a negative 42? Well, these have different signs, and we learned if the factors have different signs, your answer is negative. All right, so first you multiply, then decide what sign to put. How about negative 7 0 times? Well, of course, I don't have to think about that. And you're saying, is that a positive or a negative 0? There is no such thing as a positive or negative 0. 0 isn't positive, it isn't negative. How about this? Negative 2 times 4 times negative 3. Now we learned in the order of operations, you have to go left to right when you multiply. All right, so negative 2 times 4, I'm doing this in my head, will be a negative 8, right? Here's a negative 2 times a positive 4. I'm going to have a negative product of negative 8. Negative 8 times negative 3. Well, 8 times 3 is 24. And since I'm going negative 8 times negative 3, I'll have a positive 24, right? Because a negative times a negative is a positive. How about this one? 3 times negative 5 times negative 2 times negative 2. All right, let's start out with going left to right. 3 times negative 5 is negative 15, because I got a positive times a negative. Negative 15 times negative 2 is a positive 30. 15 times 2 is 30. Negative 15 times negative 2 is positive 30. 30 times negative 2, I know 30 times 2 is 60. A positive 30 times a negative 2 is going to be a negative 60. Because, right, if you have different signs when you multiply, you end up with a negative product. So that's just some of the stuff you're going to run into now. I got one of the most complicated things this year. I say it's not the hardest thing this year, but it is something that 6th graders get kind of confused about. Let's suppose that m equals 5 in this variable, n equals negative 8. m is 5, n is negative 8. And I want to find out what negative mn is, okay? The way you would read this is the opposite of m times n. This negative sign in front of here, it means the opposite of whatever these two are multiplied together. Here's another way to write it. It would be, you could say this negative sign represents negative 1 times whatever m is 5, 8 is, n is negative 8. So I'm going to go negative 1 times 5, and negative 1 times 5 is a negative 5. Negative 5 times negative 8 is a positive 40. So let's try it this way. If I multiply 5 times negative 8, I get negative 40, right? Because one's a positive, one's a negative, so I'm going to get a negative. What's the opposite of negative 40? Because this negative sign in front of this means the opposite of whatever m times n is. What's the opposite of negative 40? 40. So I come up with the same answer. All right? So that's just a little confusing. You got to watch out for that in today's practice. Okay, here's something else. Let's suppose that the variable p equals 5. All right, the variable p equals 5. Then what would be this negative p to the third power? Well, what does this in front of a variable represent? Well, that equals negative 1 times whatever I get here. So I let that negative be negative 1, and then p to the third power would be 5 times 5 times 5. All right, so negative 1 times 5 is a negative 5, right? So, or I could say 5 times 5 times 5 is 125. Negative 1 times 125 is negative 125 as my answer. You come up with the same answer either way. Negative 1 times 5 is negative 5. Negative 5 times 5 is negative 25. Negative 25 times 5 is negative 125. So either way, you come up with the same answer. Here's something else you're going to run into. One more thing, then you get work on it yourself. What value of x makes the statement true? If 4 times negative x equals negative 40, what value of x will make that true? Okay, so I'm saying 4 times negative 1. Remember this negative in front of a variable. I represent that by negative 1, all right? 4 times negative 1 times x equals negative 40. So I say 4 times negative 1 is negative 4. Correct? Because I have a positive times a negative, I'm going to get a negative. Negative 4 times what equals negative 40? Well, if I say negative 4 times negative 10, it would be a positive 40. X is going to have to be a positive 10 in this case. All right? So again, if you solve this using what I call that that negative in front of a variable equals negative 1 times a number, it will get you through it all the time. How about this one? Negative x times negative 3 equals negative 6. What value of x will make that true? Okay, well, let's work this out. In the place of this negative x, I put negative 1 times x times negative 3, just a step at a time, equals negative 6. What is negative 1 times negative 3? A positive 3. 3 times x equals negative 6. 3 times what equals negative 6? Well, x is going to have to be a negative 2. And that, again, one step at a time, and you will get these right every time. How about this? Negative 7 times what equals 35? That's pretty simple, isn't it? If I say, I know 7 times 5 is 35. But negative 7 times 5 is a negative 35. So x is going to have to be a what? Negative 5. Negative 7 times negative 5 will be a positive 35. Because when you multiply two negatives together, you get a positive. All right, how about this one? Negative x times negative 5 equals negative 15. Now, I've turned this negative in front of the variable x into negative 1 times x. All right? So negative 1 times x times negative 5. What's negative 1 times negative 5? Positive 5. So 5 times x equals negative 15. X must be negative 3, because 5 times negative 3 equals negative 15. Hey, this really gets you thinking, and it is good stuff. Really, I'll see you for one more math lesson tomorrow about dividing integers. One more math lesson this year. See you then. Bye-bye.